In this video, we're going to put that general equation to use and convert this binary number to decimal. So again, we know that this is a binary number because of this notation here. We have the 2 subscript indicating the base. And so if we're using the general equation from the previous video, there are 2 things we want to know. Our in value, which is essentially our number of bits. We see that there are 8, so 1, 2, 3, 4, 5, 6, 7, 8, and r, which is our base, so of course we said r is equal to 2. So from there we can essentially plug into that general equation. So we notice we have our r to the power of 0, r to the power of n, so on and so forth, all the way up to r to the power of n minus 1. So we go up to 2 to the 7th. And again, the reason for that is we're starting at 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7th. So we have each of those values and we're multiplying each of those by the corresponding bit in our binary number. So because our first bit on the right was a 0, that's what we multiply by 2 to the 0. Our next bit going from right to left was 1, then 0, then 1, then 1, then 1, then 0, then 1. So that's how we map this to our general equation from the previous video. So now we can essentially get rid of all of these terms that have a 0 in them because 0 times anything is of course 0. So we're going to get rid of those 3 terms there, and we're left with what is shown right here. Again, we know that this result is going to be in base 10, so that's where this notation comes from here. That general equation is only going from some other base to base 10, so our result is by default going to be base 10. So now we just evaluate this in the calculator. We get 2 to the 7th is 1/28, 2 to the 5th is 32, 2 to the 4th 16, 2 to the 3rd 8, 2 to the 1 is 2, and now we just add it, and our final answer then is that our decimal equivalent to that binary number is 186. In the next video, we're going to look at how to go the other way. So of course this general equation is only going from some base to decimal. What if we want to go from decimal to binary?